In this video, we're going to go over how to perform mathematical operations with Sig Figs. In other words, when you want to add, subtract, or multiply or divide measurements, we're going to have to consider both the units and how to obtain the proper number of Sig Figs to report our answer. So we're going to go over the rules. And the rules are different for addition and subtraction and multiplication and division. So for addition, if we're going to add and subtract, our measurements must have the same units. You can't add grams and centimeters. So you must, whoops, got the I. You must have the same units. If we are doing a multiplication or division with measurements, then we also multiply and divide the units. When we are doing either an addition or subtraction with measurements, we need to determine the place of the estimated digit in each number. We'll determine the place, as in the tens place, the ones place, the first decimal place, the second decimal place, determine the place of the estimated digit in each number that is being added or subtracted. Okay, if we have a multiplication or division, we don't. For this, we're going to determine the number of significant figures in each number. We'll determine the number of Sig Figs in each of our measurements. I'm writing number, but of course it has to be a measurement. Okay, so addition and subtraction, we look for the estimated digit. Multiplication and division, we count the Sig Figs. For addition and subtraction, it's going to be easier to see an example than it is to say. The least precise place of all these we've determined is where the answer has to have its estimated digit. Okay, so the least precise place, as in the tens place, the ones place, first decimal place, is the place where the answer must have estimated digit. All right, so if we have something that has 1 decimal places and 2 decimal places, the 1 decimal place is the least precise place, so our answer can only go to 1 decimal place. And again, we'll do examples to show that. For multiplication and division, we've looked at the Sig Figs in each of the measurements that we're multiplying or dividing. So for this, the least number of Sig Figs is how many Sig Figs the answer must have. So before we do any operation, we have to look at the rules for that particular operation. Okay, and then for all numbers, let me clear this. Okay, for all calculations, so for all, do the calculation first, then consider the sig figs. And you're going to use appropriate rounding when you are giving your answer. All right, so let's see how this works. All right, so let's look at this example. So we're going to look at 12. Oh, goodness. Okay. All right, we're going to look at this example. 12.58 centimeters plus 1.9 centimeters. So we're going to do the calculation. You can use your calculator. Sometimes with addition and subtraction, it's kind of easy to see if you line it up like this, like when you learned how to do subtraction. So we get 8, 9 and 5 is 4, carry your 1, 2, 3, 4, and a 1. So, and this is what your calculator will show. So now we're going to evaluate the sig figs. So for addition, we look at the place of the estimated digit. So it's the last place when we have a decimal point. So there's our estimated digit at the second decimal place, and 1.9, our estimated digit is at the first decimal place. The least precise is 1 decimal place. So that's where we're going to cut our answer off, at 1 decimal place. Now, we have to consider rounding. So we look at the next digit after where we cut it off. If it's 5 or above, we're going to round up. So our answer then is 14.5, and centimeters plus centimeters is centimeters. That is our answer. So if we had looked at the sig figs, 12.58 has 4, 1.9 has 2. That doesn't matter. What matters is where we cut it off. Then if we need the sig figs in our answer, 1, 2, 3, our answer has 3 sig figs. But we did not get that from the measurements that we used to do our calculation. 3 sig figs there. Okay, now suppose that our question was we had 12.58 centimeters times 1.9 centimeters. And we want to figure out what this equals. Okay, first of all, we just do the operation. So this one I'm going to do on my calculator. So 12.58 times 1.9 equals, and I'm just going to write down all the digits that my calculator tells me. So it says 23.902. Centimeters times centimeters is centimeters squared. If we multiply the number, we must also multiply the units. So this would be an area. A length times a width would give you an area. All right, now we have to figure out how to report this with the proper sig figs. Multiplication, now we consider the sig figs in each measurement. So 12.58 has 1, 2, 3, 4 sig figs. 1.9 has 2 sig figs. Our answer gets the least number. So between 4 and 2, 2 is the least. So we have to cut it off after 2. So we cut it off there. We look at our next digit. 9 means we round up. So our answer is 24 centimeters squared. And you can put the decimal point there or not. It doesn't matter because 24 centimeters squared shows 2 sig figs. If you wrote this as 24 decimal point centimeters squared, that would also show 2 sig figs. So this does not matter. Okay, let's do a few more examples. So for our next one, we will look at 38.6 milliliters minus 31.26 milliliters. Now this is subtraction. Don't even bother checking the Sig Figs. That's not how we do it. So again, we're going to get our number. You can do it on your calculator. I'm just going to line these up. All right, 6 minus 6 is 0. 6 minus 2 is 4. 8 minus 1 is 7. So we get 7.40 milliliters minus milliliters is milliliters. All right, we have to look at the estimated digit location. So at the second decimal point, it's the same. Our answer must go to the second decimal place. So your calculator might have shown 7.4, but you must write the answer as 7.40 milliliters, because we must have two decimal places because both of our measurements have two decimal places. So that's our answer. And then if we need the Sig Figs in our answer for whatever reason, 1, 2, 3, our answer has 3 Sig Figs. Again, that has nothing to do with our two measurements. That has 4, but our answer ends up with 3 because we follow the rules for subtraction. Okay, let's do another example here. We have 25.480 grams divided by 9.44 centimeters cubed. And we want to know what that's equal to. So first we're just going to do our calculation on our calculator. 25.48 divided by 9.44 equals. Okay, and I'm just going to write down a whole bunch of digits here. I know I'm not going to need all of these. My calculator's saying 2.69915 and a whole bunch of other digits. My units are grams divided by centimeters cubed. We divide the measurements, we divide the units. So now I have to figure out how to report this number. And now, since I'm doing division, I look at the Sig Figs in each measurement. So my top measurement is 1, 2, 3, 4, 5 Sig Figs. The denominator has 1, 2, 3 Sig Figs. I go with the least number of Sig Figs, which is 3. So my answer gets 1, 2, 3. I'm going to have to cut it off here. I look at the next digit. It's a 9, meaning I have to round up. So my answer is 2 point. Rounding that up, basically 69 goes to 70. You get 2.70 grams per centimeters cubed. And if I need the Sig Figs, 1, 2, 3. 3 Sig Figs. Okay, so it's very important whenever you see an operation or you're doing addition and subtraction, you look at the decimal places or the estimated digit place. If you're doing multiplication or division, then you're looking at the Sig Figs in each number. Okay, let's do more. Okay, let's look at this one. 52 grams plus 0.0003 grams. And again, in addition, you must have the same units. So when we add these, we get 52.0003 grams. But now, remember, with addition, we have to look at the place of the estimated digit. So for 52, our estimated digit is our last digit. It's that 2 in the ones place. Here, our estimated digit is all the way at the 4th decimal place. The least precise is the ones place, because as you get more and more decimal places, you're getting more and more precise. So our answer has to get cut off at the ones place, just like our least precise measurement. So our answer to this, which might seem crazy, is 52 grams. This 0.0003 doesn't matter. And that's because if I'm estimating at that place, that means it could be 51, it could be 53. I can't say anything beyond that place if I don't even know exactly what that place is. And with measurements, we never know for sure what the last place is. That's our estimated digit. So an example of how could you have that? You add something and it doesn't show up. Imagine you get on a scale to see how much you weigh, and then a fly lands on your head. Is the number on the scale going to change? No, because the weight of the fly is insignificant compared to how the scale measures. So 52 is the answer there. So that some of these answers may be surprising. All right, now we're going to look at what happens if we have mixed operations. So now we have to take the rules of both addition and subtraction and multiplication and division into account. All right, so for mixed operations, we're going to do the entire calculation on our calculators, get a whole bunch of digits. Then we're going to go back and follow the rules for each operation to determine the Sig Figs. And of course, we're going to determine the proper units as well. So here is an example of that. All right, if we have this, 16.7 grams divided by 23.4 milliliters minus 21.4 milliliters. And we want to know what that equals. All right, so like I said, we're just going to do the whole calculation on our calculator, see what we get. 16.7 divided by, and our calculator gives us 8.35. Our units are grams in the numerator. In the denominator, we have milliliters minus milliliters. That's just milliliters. So our units are grams per milliliter. Now we need to figure out our Sig Figs. So we're going to do our operation in parentheses, just like we do with our calculations. And we see that 23.4 minus 21.4, well, that's 2. However, one decimal place, our answer must have one decimal place. So your calculator is going to tell you 2, but we have to do the answer as 2.0 because of the rules for subtraction. And the unit there would be milliliters, but that doesn't matter. We've already figured out our units. Now we're just trying to do our Sig Figs. So now we have a division. We have our numerator has 3 Sig Figs because in division, we have to look at the Sig Figs in each operation. Our denominator that we already figured out, 2.0, has 2 Sig Figs. So our division, 3 and 2, the least Sig Figs is 2 Sig Figs. We have to cut our answer off at 2 Sig Figs. And then we check the next digit. It's a 5, so we're going to round up. So our answer is 8.4 grams per milliliter. Okay, so again, do the entire calculation on your calculator, write down a bunch of digits, then go back and treat each operation separately. All right, so now I think that I'm going to give you some practice. So let's do that. Oh, no, I forgot. We have to talk about exact numbers. So if we have counting numbers, let's say there's people in a room and I count them up. Whoops. Okay, I count them up and I count that I have 15 people in the room. This count of the people is not a measurement. This 5 is not an estimated digit. It's not maybe there's 14, maybe there's 16. I counted them. There's exactly 15. There's no estimation there. It's not a measurement. So this has unlimited sig figs. If we wanted to talk about sig figs, so we could say infinity sig figs. It's not limited because we're not estimating. When you're doing a percent calculation, you do the part over the whole times 100. The 100 in the percent calculation is exact. That means the 100 has unlimited sig figs. So here is an example of that. So if we had, say, 85.8 grams divided by 150.2 grams times 100. So now we do the whole thing on our calculator, right? Get a bunch of digits. So 85.8 divided by 150.2 times 100 equals. So my calculator tells me 57.1238. Okay, I go back and look at my sig figs. In the numerator here, 85.8 has 3 sig figs. My denominator has 1, 2, 3, 4 sig figs. This times 100, this is not a measurement. It doesn't have a unit after it. Measurements have units. This does not have a unit. This has unlimited or infinity sig figs. So the least of 3, 4, and infinity is 3 sig figs. So my answer needs 1, 2, 3. I cut it off there. So I get 57.1, and then the unit is percent. The grams over grams cancel, the grams cancel, and then times 100 means you're doing 8%. All right, and then when cutting a measurement in half, the 2 is exact. And I have the next slide will have an example of that. And here I just want to emphasize a number without a unit is exact. Measurements have units. This is just a number. There's no unit. We don't look at sig figs for that. Okay, so let's look at our next example here. All right, the diameter of a cylinder is 8.42 centimeters. What is the radius of the cylinder? So our formula is that our radius r is equal to the diameter divided by 2. So our radius, our diameter is 8.42 centimeters divided by 2. So we do that division and we get 4.21 centimeters. Nothing cancels out. And for the sig figs, 8.42, this is a measurement. This has 3 sig figs. This 2, there's no unit after that. This 2 is not a measurement. This is considered to be exact and have infinity sig figs. So the least sig figs is 3. 1, 2, 3. This is correct. So look out for when you need to consider sig figs and when an exact number has unlimited sig figs. Okay, so now we'll do some examples. All right, so here are some practice problems. So what I would like you to do is pause the video and do all of these calculations and report it with the proper significant figures and units. And then come back when you're finished and we'll see how well you did. Alrighty, so let's go over the answers to these. So our first one is an addition. So of course we just do our calculation out, and on your calculator, you will get 42.47 meters plus meters plus meters is meters. Now we have to look at where we're going to cut this off. For addition, we cut it off at the least precise place of the estimated digit. Here, it's at the second decimal place. For this number, it's at the first decimal place. For this number, it's at the ones place. The ones place is the least precise, so that means I have to cut my answer off at the ones place. I look at the 4, I do not round up, so my answer is 42 meters. And if you have the decimal point there, that's fine. It doesn't matter if you have it or you don't have it. Our answer ends up with 2 sig figs. Doesn't matter how many sig figs are in each of these numbers. We're not looking at that for the addition. We look at the place of the estimated digit for our addition. All right, our next one, 55.5 minus 0.06. So when we do that, we get 55 on our calculator anyway, 55.44 grams. It's subtraction. We look at the estimated digit place in each of our measurements. So here we're at the first decimal place. Here we're at the second decimal place. So the least precise is the first decimal place. We have to cut it off at the first decimal place. We do not round up. So our answer is 55.4 grams. All right, for our next one, 6 times 7. Everyone knows their times tables. 6 times 7 is 42. Centimeters times centimeters is centimeters squared. But this is not the answer to this problem. We haven't figured out our sig figs yet. 6 centimeters has 1 sig fig, because now we're doing multiplication. We do look at the sig figs in each measurement. 7 centimeters has 1 sig fig. So our answer has the same as the least. Our answer has to have 1 sig fig. 42 has 2 sig figs. So we have to write this so that we have 1 sig fig. However, we want to say 4. We have to say 40 centimeters squared has 1 sig fig. We have to say 40 because 42 is in the ballpark of 40. The 0 is a placeholder. The 4, this is where our sig fig is. So 42, 6 times 7 is 40 when we're doing measurements. However, if we have 6.0 times 7.0 centimeters, 42 centimeters squared, this has 2 sig figs. 7.0 has 2 sig figs. So our answer needs 2 sig figs. So this is the answer. So 6 times 7 is 40. 6.0 times 7.0 is 42. Because these measurements, we would consider this estimated digit, so maybe it was 5 centimeters, maybe it was 7 centimeters. This, maybe it was 6, maybe it was 8. So we can only have 1 sig fig in our answer. Here, now, this is our estimated digit. So maybe it was 6.1 or 5.9. So we have better measurements, we get a better answer. All right, so in this one, we're doing division. So we have to first do our calculation on our calculator. So let's see what we get. So 89.76 divided by 3.4 equals, and we get 26.4. Meters cubed over meters is meters squared. So we'll look at that. We have meters cubed over meters. So that is meters squared for our unit. All right, we have to do our sig figs. 89.76 has 4 sig figs. 3.4 has 2 sig figs. It's division. Go to by the least sig figs. You need 2. Cut it off there. So our answer is 26 meters squared. All right, and then our final problem. This is a good one. Now we have mixed operations. I'm going to erase the rest of these so I have room to do this. All right, so with our mixed operations, and I'm going to write this, 158.20 grams minus 151.00 grams over 151.00 grams times 100. We're going to be seeing lots of calculations like this in chemistry. Okay, so what are the rules? Do the whole thing on your calculator and get a whole bunch of digits. So 158.2 minus 151, I guess it ain't my calculator for that, divided by 151 times 100 equals. All right, so I'm going to write a whole bunch of digits down. 4.7682, da-da-da-da-da-da. Grams minus grams is grams, and grams divided by grams cancels out, times 100 means we have a percent. Now I do the sig figs. I'm going to do the sig figs for the subtraction. When you subtract this on your calculator, you're going to see 7.2. But our first measurement has 2 decimal places. The second one is 2 decimal places. For subtraction, our answer has to have 2 decimal places. So I got to put a 0 there. So that is the result of the subtraction. Now we're doing a division with our numerator and our denominator. In our numerator, we end up with 1, 2, 3 sig figs. Our denominator is 1, 2, 3, 4, 5 sig figs. So 100, that's not a measurement. There's no unit after it. This has unlimited sig figs. So from our division, we go with the least, which is 3. So 1, 2, 3, we cut it off there. We look at the next digit, we round up. So our answer is 4.77%. Okay, so these can be a little bit tricky, and I know what students usually like to do is they usually like to look at the sig figs in each number. This has 5, this has 5, this is 5. Oh, let's do 5 sig figs. That is not correct. Do not do that. You have to do the subtraction, get the proper sig figs for the subtraction, then do the division, then you look at the sig figs in each number. So pay attention to the sig fig rules.